You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So I feel like some people would think that this is a big O n problem, but I think it's just a complicated math problem that you could do in big O1, constant time. So my instinct is to figure out this math problem. So each time you can either go up 1 or go up 2. And so something tells me that this is basically some kind of n times n solution where you just multiply n by the right constant and add some constant. It's not much of an algorithm. What's the time there now? My current time zone is Eastern time, if that's what you're asking, Sandeep. It's 2 p.m. here. So how many different ways can you climb the stairs? I'm trying to think of how it expands each time. Maybe we can think of it, let's say if there's like a pattern that forms. So if it's 1, then it'll be 1. If it's 2, it'll be 2 because you can go 2 or you can go 1. If it's 3, it's 1, 2, 3. Welcome. Thanks for joining. Yeah, I used to work with somebody in India, so yeah, I'm familiar. With the 12-hour or so difference. So for the 3, it'll be a little bit more complicated. We could do 3 1s, we could do 2 1, we could do 1 2, which would be 5. But this is saying n equals 3 is 3. Oh, my bad. This is 1. That's just, this one is a 1 combination. Of course it is. And then 4 would be 4 1s, 2 1 1, 1 2 1, 1 1 2, 4 1s, 1 1 2, 1 2 1, 2 1 1, 2 2 2. Is there a formula emerging here? 5 is even correct. We definitely don't want to do this in big O N, so we just want to figure out the formula. It kind of looks like, what's that one? Bernoulli? No, Fibonacci. Yeah, Fibonacci. It's something like this idea that you can do all the previous combinations plus this new one. But in order to do a Fibonacci sum, you need to do recursion. Actually, yeah, this because it's basically the n. It's just a really weird way of doing Fibonacci because you are trying to do f of n plus f of n minus 1, something like that. Oh, good night. Thanks for popping in. With some base cases of if n equals 0, return 1. N is 1, return 1. If n is 2, return 2. It seems like it's Fibonacci, but I don't know. Oh, why did I call it F? But is it? Yeah, I don't think you could do. You could do Fibonacci a little bit faster if you didn't use. If we didn't use recursion, we could do it faster. So we could do const result equals 1. I don't know. Call it other equals 1. And we'll say while n, and we'll return result. These should be lets. And we'll do result equals result plus other. I think we got to do const temp equals result. And then other equals temp. Something like this. It's been a while since I've done Fibonacci sequence. Oh, we didn't end minus minus. So we put 3, but we expected 2. N was 2. So if you say 0, and that should bring us down by 1. Output is 1. Expected 2. And this gives us 3. Alright, let's think about it. Result is 1, other is 1. N is 2, so let's write that down. We'll put this on a new line. Put a 1 here, put a 1 here. This would be 1. Result will become 1 plus 1, which is 2. Other becomes temp, which is, it should be 2. Becomes 1. So maybe we have to do greater than or equal to 0. The result is 0 initially, and we'll try that. Okay, we can get rid of our comments. Double check, run it one more time. We'll submit it, see how we did. We really didn't have to optimize because we were already at 0 milliseconds, but this is faster because it will be big O n rather than like n plus n essentially. It's actually a lot more complicated than that. It's actually really hard to calculate what it would be recursively because each left and right call would be another like n minus 1, n minus 2, which is basically big O n. So it's a little complicated. But this is easier. This is just n. A lot easier to reason. We can look at the other solutions. And they did what we did. They created a temp variable. I mean, they did things a little bit different in the order, but we had the same ideas. Look at the solution. They did Fibonacci. And they had like some kind of map variable. And this is just so they can cache certain values for n. So this would save them a few iterations, but this uses more memory. So you're going to use n memory. So that's the sacrifice. You improve performance, but you hurt memory for this one. And then climb stairs. This is also a Fibonacci sequence. And they also cache the values. So this is also using more memory. This is probably also slower because it uses a console log. But I'm happy with that.